All right, so gonna do a problem here, and it states that a ball is thrown upwards. Actually, okay. So Roadrunner comes, and and this is my well, okay. This looks more like a cow, but I'm just gonna call it the Roadrunner. Now it's starting to look like you know, it's a happy dog. A happy dog comes by and scares the devil. Uh, Mickey Mickey Mouse. Okay, Mickey Mouse person. And this person, Mickey Mouse person, jumps up in the air at 20 meters per second. Okay, so they're on this cliff here, and it's 30 meters high. So this entire area here is 30 meters. Um, and this Mickey Mouse person climbed up terribly high to try and get Roadrunner, Coyote, Dog. Okay, I have no idea. Anyways, so we don't really care. So we can write this or model this situation based on Newton's laws, where force is equal to mass times acceleration. We know force is equal to mass times acceleration can be written as dv dt, or the change in velocity over time. In this instance, we're not needing to worry too much here about mass. That will come later, but mass is kind of arbitrary with gravity. So change in velocity over change in time. So we know that gravity works in the negative direction, right? And the force of gravity is equal to 9.8 meters per second squared, I believe. And so we can write this as the change in velocity over change in time, and we're going to assume that there's no um, like wind drag at the moment. We can do that here in a little bit. But so just picture in your head, he jumps up in the air, and as time goes on, okay, actually, let's go back a little bit. Okay. If you were to jump up in the air, you speed up, or sorry, you don't speed up, you constantly are slowing down, right? So if I were to actually try and do this, I would start really fast, and then I would start slowing down, and then it looks like you're slowing down. You are slowing down, but the acceleration is constant. Think of it this way. Say that you were speeding up in a car, right? So this is your velocity over time. Well, if we take the derivative of velocity, it's a straight line, right? So we don't have any variable with this. It's just negative 9.8. And we can, and that's all for this problem. So we can separate variables. We have dv is equal to negative 9.8 dt. And so we have velocity is equal to negative 9.8 t plus c. All right, so we have an arbitrary constant here. What do we do with it? Well, we know the initial velocity was 20 meters per second. So what we can do is set 20 meters per second for our velocity at t equals 0, right? So 20 is equal to negative 9.80 plus c. Well, this goes away, and we're left with 20 is equal to c. So for this graph, well, okay, so we know with a slope field, if we were to actually you know, graph the slip field with this arbitrary constant, we would have an infinite number of solutions, right? So at any point time, at any time t, we have, um, you know, an infinite number of solutions. So we don't really need to graph that at the moment, but if you want to, you can Wolfram alpha it or something. Okay. So 20 is equal to c. We have velocity is equal to negative 9.8 t plus 20. And if you were to look at like a physics, equation or whatever for velocity, that would say like, v is equal to negative 9.8 t plus vi for, initial velocity. So now that we have this, how do we figure out when he is up at this highest point? Well, if we wanted to try and picture this here, what we have is he's up here, he comes up and goes down, right? And so what we want to find is where velocity is 0, right? So what we can do, and this is really easy, is we set the velocity to 0. In this instance, there's only one point where velocity is going to equal 0. We don't have a square or anything here, so this is velocity is equal to 0, negative 9.8 t plus 20, and then we have negative 20 over negative 9.8 equals t, and let me just throw this in a calculator real quick. 20 divided by 9.8, 2.04, t is equal to 2.04082. All right, so at time t, my handwriting, t is equal to 2.04082, and velocity is 0 at that point. All right, so how do we actually figure out where is at what height? Well, we have this equation for velocity. Change of position over time is velocity. So if we want to get the position instead of our change of position here, this is dp dt, change in position or change time. We would need to integrate this. So keeping in mind this information later on, we have dp dt is equal to negative 9.8 t plus 20, and so this is easy, right? dp is equal to negative 9.8 t plus 20 dt, and so we have p is equal to negative 9.8 t squared over 2 plus 20t plus c. We have again our arbitrary constant. All right, so what information do we need here? Well, we need to fill in our constant here, and the way that we do this again is to set time equal to 0 and fill in the information that we have. So our initial position was 30 meters up in the air, so we can write 30 here is equal to negative 9.8 over 2 t squared plus 20 t plus c. Well, this goes to 0, this is 0 because we're multiplying t at t0. C is equal to 30, so we can write p is equal to negative 9.8 over 2 t squared plus 20t plus 30. And so at what height does he reach? Well, that's easy because we have the height at velocity 0 and our time up here, which is 2.04. we'll just say approximately, so P is equal to negative 9.8 over 2 times, what was it, 2.04 squared plus 20, 2.04 plus 30, and plugging that in, hold on, negative 9.8 divided by 2 times 2.04 squared plus 20 times 2.04 plus 30, which equals, position is equal to 50.4082 meters. So we had it where, velocity was 0, which is up here, got our time there. And that would make sense too, because if we wanted to find our change in position over time, we would take the derivative. Whenever that derivative is positive, it's increasing. Whenever it's negative, it's decreasing. So this is good here. If we were to look at this up here, it's positive until this is equal to 20, and then after that it's negative. So it's slowing down, right? Or it's going backwards. Okay. All right. Anyway, so next we want to find out where he ultimately hits the ground. So this is the highest. The only other thing that we would need to do is set our position equal to 0 is equal to negative 9.8 over 2 t squared plus 20t plus 30. Okay, so this is a quadratic equation. So what we would do is okay, all right, so what we do is use the quadratic formula. So we've got negative b plus or minus square root of b squared minus 4ac all over 2a. And what have we got here? This is our a, b, c. So we've got 9.8 over 2 plus or minus square root. Oh, did I just do that? I just did that. Okay. All right. Negative 20. B, A, B, C, negative 20 plus or minus square root of 20 squared minus 4, negative 9.8 divided by 2, 30, all over, okay, so this is 2a, so this is 2 times 2, so this is just negative 9.8 down here. And if you want to solve that, Jesus, okay, I'm gonna see if I can just do this the easy way. Let me just plug it in. Algebra, polynomial tools, find roots. Okay, this is a degree 2. I really hate arithmetic. All right, so we've got negative 9.8 divided by 2, and then we have for 20, and then we have 30. Okay. Okay, so our roots. Oh, fuck. Menu. Because I refuse to do more arithmetic than I have to. I rely on technology. Okay. Negative 9.8 divided by 2. God damn it. Okay. Fantastic. Okay, here we go. Negative 9.8 divided by 2. And then 20, and then 30. Okay. All right, so we have 2 times. We have, because this is a quadratic, we've got the t squared. This is going to give us 2 answers. Well, it doesn't make sense to have a negative time. So the 2 answers would be negative 1.1665 and 5.2482. Well, that doesn't make any sense. This is the only possible solution. So at time where he is at height 0 would be 5.24 seconds. All right. And if you have any questions, just go ahead and let me know. All right. I will see you later.